Hello and welcome, and in this tutorial we are going to work on what we made on last lecture, but we're going to make it so the LED blinks. Currently, last lecture we just hooked up the power and ground to the LED so that it powers on. Let's now make it so it blinks. We're going to do this programmatically, so let's get to it. Okay, so the first thing we do, let's start the simulation, and I just want you to ignore this LED for now. Just scroll in to the Arduino here. Notice you see this blinking light. Well, this is linked to pin 13. And pin 13 is a great pin to use for making stuff blink. So essentially these are all digital pins, right? So they can output current or they output no current. That's how it works. I just want you to stop the simulation, click the Arduino and press code. You'll see all of these blocks. This is kid stuff. You want to learn this properly. So let's change from blocks to text. And you'll see a nice little C program here, okay? So this setup function here is the function that Arduino calls when the Arduino is first turned on. And the responsibility for this function is simply to set up things that are essential for your circuit to work. So for example, in this instance, we set digital pin 13 to an output pin. Now, some pins are input pins so they can receive information. Other pins are output pins so they can output information. Now, by setting pin 13 to output, we're essentially saying we want to be able to output current to this pin programmatically. So now, let's explain this loop function here. What's happening here is Arduino calls this incrementally, like very frequently, basically. And inside of here, we do a digital write to pin 13, and we make it high. Now, high means current. Low means no current, okay? So high means power, low means no power, okay? So what we say here is set pin 13 to high so that there's electricity that'll run out of it. And then here we delay for 1,000 milliseconds, which is 1 second, by the way. And then we turn it off. We set it to low. So, and then we wait another 1 second. So let's just reconfigure our circuit so that it uses pin 13 so it blinks. Again, if we press start simulation, the reason we see this LED blinking here is because this is linked to pin 13, okay? We're now going to make it linked to our real circuit here, so that we see our LED blinking on the board. Alright, stop the simulation. We need to change some wires around. So first thing you do, I want you to delete this wire here by selecting it and pressing the delete key. Okay, great. Now, we're just going to press code again here to close this, okay? And we're going to scroll in here. We're going to click pin 13. We're going to scroll out. And we're going to click our resistor here. Well, the same line the resistor's on. We're going to change this to red to represent power. Now just press start simulation. You now notice that the LED blinks. It goes on, off, on, off, on, off. Now that is because of our program. If we go back to code by pressing code, we digital write to pin 13, high, we delay a second. Digital write to 13, low, delay a second. And again, pin 13 is clearly represented on the board and our wire is attached to it. Okay, I hope that makes sense. Let's change it so that there's a delay of 5 seconds. So just press the code view, change the one. First you need to stop simulation, press the code view, change the 1000 here to 5000. Okay, so that'll delay for 5,000 milliseconds, which is 5 seconds, guys. So press start simulation. Now we see that it's on. Looks like it's stuck on, right? No, after 5 seconds it'll go off. There we go, now it's off. Now another 5 seconds. Again, looks like it's off forever. After 5 seconds, it's back on. So, that's essentially what we're doing here, right? And let's change the delay to something very small. Stop the simulation. In fact, let's remove the delays entirely and you should see that it looks like it is stuck on constantly, which we do. It looks a little dim because it's constantly putting current, removing current, putting current, removing current constantly, right? So that's why we need a delay there. If we put a delay here of 1000 like before, and then we delay another 1000 here, then we'll see that it blinks once more. So you just programmed your very first circuit. So I hope you're proud of yourself there. So once again, let's go over this. The setup function is called when you first turn the Arduino on. The loop function is called very frequently. Okay, so just to make a good end to this tutorial, let's change the pin it uses, okay? So I want you to change in the code, I want you to change the pin to 12, okay? And just go 12 high, digital write 12, digital write 12. Okay, so we set the pin 12 to an output pin, which means we're outputting, right? If it's an input pin, we receive current. We receive a high or a low. If it is a output pin, we output to that pin, okay? And we're working with digital pins currently. There's analog pins, but we'll get on that at another time. Okay, so you should have changed the pin to 12 now, okay? Press start simulation. And what's this? The LED doesn't light anymore. And also the LED on our Arduino is no longer lighting. That's because we changed our code to use pin 12. If you now stop the simulation, delete this wire by selecting it and press the delete key on your keyboard, we are going to select pin 12 and put a wire. We're going to scroll out with the mouse wheel, and we're then going to put that there, change it to red, and now you should have a circuit that looks like that. So there's a wire from pin 12 to our resistor, which then feeds the current to the LED. Press start simulation. We see it's on, off, on, off. Excellent. So I think you now understand what's going on here, right? We set up a pin for input or output, and then we can write or read from it, essentially. You haven't looked at reading yet. This is just writing at the moment. Again, we'll get to that another time. So examples of reading, by the way, might be a button press. We might have a button on our board. We might want to see if it's pressed down. Then we'd read, right? So we would connect this to a pin just like we've done here, and then would read from the pin and that would tell us if there's current going into that pin or not, i.e. the button being pressed down. I hope you've enjoyed these course previews. To purchase the course, please use the link in the video description. Every course purchase allows me to make more content and keep bringing value to you.